Hello. Today's video involves applications of the extreme value theorem. Which we usually just call EVT. To remind you, EVT says if f is continuous on the closed interval AB, that's all I need, then that implies there exists some values C and D in that closed interval where f of C is the absolute max of the function on that interval, f of D is the absolute min. So if I have something like, suppose this is my continuous function, this is on my closed interval, there's some value C, in this case C is the right hand endpoint where f of C is the absolute max, and there's some value D, in this case D is right here, f of D is the absolute min of the function on the interval. Okay? So I'm going to use two of the problems or situations that we had from the last video, the two of the functions. We had problem 1b, f of x was equal to 16x to the 1/3 minus x to the 4/3, and now I'm going to, that was, we didn't have any closed interval when we did this before, finding critical values. Now I'm going to give a closed interval so that EVT applies, and I'll use the interval -1 to 8. Remember my critical values that we found previously were x equals 0 and 4. To find the absolute max and min, all we need to do is compare functional values. The absolute max and absolute min must occur at either a critical value or the end or an endpoint of the interval when EVT applies. Whenever we have EVT applies, this is the situation. So f of 0 is just going to be 0. Notice here I am substituting these back into the original function, not the derivative function. F of 4 is going to be 16 times the cube root of 4 minus the cube root of 4 to the 4th, which, using some algebra, this is 16 cube roots of 4 minus 4 cube roots of 4, or 12 cube roots of 4. Endpoints, f of -1 is, cube root of -1 is -1. The cube root to the 4th power is +1, so this becomes -16 minus a +1, or -17. And then f of 8, cube root of 8 is 2, so we get 32 minus 2 to the 4th, which is 16, and this value comes out to be 16. And so at this point, I will, well, let you determine, but obviously this is going to be your absolute min. It's the only one of these that is negative. And if you use a calculator and check, you will find that this is the absolute max. You should check that on your own. One more example, again, one that we looked at before, the piecewise defined function. We had my critical, well, let's write the function up. My function, g of x, is x plus the natural log of x squared minus x minus 1 for x less than negative 1, and x cubed minus 2x squared plus x plus 3 for x greater than or equal to negative 1. I'll give this an interval, negative 3 to 3, let's say. And remember our critical values that we determined last time were x equals negative 2, negative 1, 1/3, and positive 1. There were 4 critical values. And so I'm going to end up with 6 values to compare at the end. F of negative 2 would be, make sure we put this into the correct piece. That would be the top one in this case. Negative 2 plus the natural log of 4 plus 2 is 6 minus 1 is 5. F of negative 1. In this case, I remember I said the function was continuous. It wouldn't matter which of these we put in, but technically I'm going to put it into the bottom one. Negative 1 minus 2 is negative 3. Minus 1 plus 3 is negative 1. F of 1/3. Again, I need to use the bottom function. That's going to be 1/27 minus 2/9 plus 1/3 plus 3. And I'll let you figure out what that is. And F of 1 would be 1 minus 2 is negative 1, plus 1 is 0, plus 3 is 3. We then need the endpoint values. F of negative 3, I'm using the top function again. Negative 3 plus the natural log of, let's see, 9, 12, minus 1 is 11. And F of positive 3 comes out to be, now I'm using the bottom, 27 minus 18 is 9. Yeah, making sure I have this correct. 27 minus 18 is 9, plus 3 is 12, plus 3 is 15. And so we would have to compare these 6 values. Again, I will leave this to you. Whichever one is the largest would be the absolute max of the function on that interval. The smallest is the absolute min.